Thank you, everyone, for joining our virtual roundtable on orchestrating projects with a million lines of code. Today, we have an amazing panel that I'm sure, I think our biggest challenge is going to be cutting it down to 45 minutes. So we'll do my best as your host and moderator to help. And if not, we'll just invite you back for a part 2 or part 3, whatever we need, because this is a subject that is near and dear to our hearts. And of course, with that comes a lot of passion and great insight. But before we begin, I just want to give you a little bit of some housekeeping. So on the Zoom webinar, everyone will be on mute, but that doesn't mean we don't want to hear from you. So please put in your questions in the Q&A section, and we will try our best to answer those. And whatever we don't answer, we will be happy to follow up with you afterwards via email. So with that, my name is Yochai West. I am a Senior Product Marketing Manager at Incredibuild, and I would like to introduce our esteemed panel. But let's let you guys introduce yourselves, a quick line about your responsibilities in your company. And then with that, we'll jump straight into the questions that we have for the panel and the discussion that I'm looking forward to. So in random order on my sort of matrix of the Brady Bunch, Titus, Father Brady.
Thanks. Yeah, I'm Titus Winters. I'm a software engineer at Google. I've been based in New York for 10, almost 11 years. I'm by and large in charge of the C++ code base. It's about 250 million lines of code with roughly 12,000 30-day actives. That is engineers that will commit a change in C++. My teams run all of the low-level libraries in there, as well as style guide and best practices. I served for a little while on the C++ standards committee, and yeah, that's the care and feeding of very large code bases has sort of been my life for the past decade.
Nice. So on the topic of C++, Amir, why don't you take us to who you are?
Hi. Amir Kirsch. I'm a dev advocate at Incredibuild and a lecturer at the Academic College of Tel Aviv-Yafo and Tel Aviv University. In parallel, I'm co-organizing the Core CPP conference and meetup here in Israel, but it is an international meetup nowadays with Zoom. And a member of the national body, ISO C++ Israeli national body.
Thank you, Amir. And so we don't make this a total C++ boys club. David Schwartz, tell us about yourself.
I'm David Schwartz, Chief Architect at NI Israel, technically. And I handle all the architecture and design for their analytics platform known as Optimal Plus. In my spare time, I enjoy breaking apart monoliths, which I've been spending a lot of time on now, working on some of our more legacy code, which is where I get to the large code bases, and migrating things to .NET Core. So definitely this topic's interesting to me.
Fabulous. And Ed, can you go ahead?
Yeah. Hey, everybody. Thanks for joining for the panel. Looking forward to this. I am Ed Keane. I run the container adoption practice at Red Hat, specifically inside Red Hat Consulting. So helping our customers get up and running with OpenShift, which is really like the platform that we built on top of Kubernetes, helping them containerize their applications, get familiar and dive deep into Kubernetes and the ecosystem around it, start building cloud-native pipelines, all things hybrid cloud and DevOps.
Fabulous. And that is a red hat behind Ed.
It is indeed a red fedora, yep.
It is. And last but certainly not least, Marc Ullman.
Hi, I'm Marc Ullman. I work at MathWorks. I've been there for over 25 years and lead our infrastructure, architecture, and tools team. We have a very large code base, which is continually evolving, made up of multiple languages, including C++ and many others. We support both desktop and cloud applications, so sort of spans the full gamut of the things that you heard from everyone else here.
So folks on the panel, how many of you have worked with Matlab? Give a quick raise. Wow, there we go. All right, we found the common bond. I appreciate that, Marc. 25 years. That's very impressive, and I'm sure that experience will come through our conversation today. So with that, I like to start off with a personal question because, different challenges in understanding trends that are out there. So on the one hand, we know that the code bases are growing and they're getting more complex, right? But we also have microservices, smaller things, breaking down things. How do they live? How do they live together in the world of million lines of code, which is the topic of our webinar? But we also have microservices. But microservices is not a new thing. It's been around for decades now? I'd like to understand, guys, can we make up our minds? What the heck are we doing right now? Are we going to the major, million lines of code projects? Are we doing, going full strong in microservices? How do we even understand microservices in our world? And I like to first start off with Marc, because Marc, in our sessions prior to this, you had mentioned a couple of interesting things about working on open source microservices projects on your spare time when you're not at MathWorks possibly. And I wanted to get your perspective on what is this dissonance? What is this challenge between these two major topics?
So, just a quick clarification, not so much that I've been working on them personally, but MathWorks is doing that. So don't want to take credit for the work that others are doing. So it's an interesting, as with most things, there's a balance. And so certainly we continue to try to leverage microservices and other forms of modularity, but they actually come with a cost that when you have a really large code base, you have lots of microservices, especially if those are like C++ microservices as opposed to the classic separate processes microservice, then you're loading lots of things dynamically and you start to run into limitations, believe it or not, at the OS level. And so, for instance, we found that our load times on the Mac were very slow as we got bigger and bigger, and we worked with Apple to reduce that by an order of magnitude by improving their loader. We're seeing the same problem now with Linux, and we've worked on some improvements to the Linux loader to speed up startup time when you're loading literally thousands of DLLs. So definitely modularity and breaking things up is a good thing, but it comes with a cost when you start to put pressure on the underlying infrastructure.
So I remember, Marc, you mentioned you had that definition of what microservices is. What would that be?
So microservices in our case is things where we're dynamically loading on demand different aspects of our application to meet those requirements. And so it allows us, as you mentioned, to break it up into a more modular fashion so it's not so monolithic. It's basically a plug-in architecture. So extensibility.
Right. And David, you had once mentioned, what would a webinar be without a quote from Uncle Bob? What are your thoughts on microservices as a whole, again, with this dissonance and dilemma with a million lines of code?
I mean, a couple of things here. The first is the motivation behind going to any kind of modularity, but specifically microservices, is the fact that people can't keep too many things in their mind at once. There's something known as Miller's Law. It's a classic psychological principle that a person is only capable of working in their working memory of having 7 plus or minus 2 things at the same time. The idea of microservices is to isolate things. So you're not dealing with a million lines of code anymore. You're dealing with a much smaller piece of your application, which stands by itself. Usually the classical microservices, at least from, if you read the papers on it, the idea was to actually have them be separate processes. Marc's case is actually more common in the industry, but usually it's separate processes which are communicating over HTTP. The idea was to say all of the stuff that has to do with something, let's, I don't know if it's a bank, account handling is going to be in one process where you're going to make calls to it. And that allowed people to function better and to understand that they only had to understand one thing at this point. They're only dealing with account balances. And if they were dealing with something else, they would be in a different, they would be in a completely different application, which only handles, transfers and things along those lines. The sticking point is, if you want to quote Uncle Bob, definitely, he says software architecture is the art of drawing lines that I call boundaries. Where do you draw those lines? Because if you don't draw them well, what you end up having is all these different microservices, which are all talking to each other, and then they're not really separated. In other words, for your brain, the only reason to change code has nothing to do with the computer. The computer could care less how your code is organized. It's for human beings to be able to work with it. Well, you can't work with a huge code base that's broken into teeny services, all of which are dependent on each other. You've just basically taken microservices and turned it into a distributed monolith. And that makes it even worse than a regular monolith. So it's very tempting to say, hey, it's popular today. I'm going to write this in this module and this in this module. Yeah, well, in order to make a transfer, the transfer has to talk to the account. And it also has to talk to the monetary changing library. And by the time you're done, you have 7 or 8 microservices in your flow. And you don't have microservices at all. You have a distributed monolith, and it's really difficult. So it's really an art form, knowing how big or small to make each of those microservices, and also where to draw the lines. I think that's really the art of architecture at this point, is drawing those lines in the right places. I think microservices as an idea is great. I sometimes joke that we should be aiming for, medium services, or I don't know, instead of
microservices.
Like something a little bit bigger than a microservice, but that's actually handleable and that prevents your system from becoming completely, totally coupled in a different way across HTTP calls.
Titus, Ed, what do you guys have to say on that? Whoever unmutes first.
All right, yeah, I'll jump in here, David. I love the way you put it as being like a distributed monolith and having all the dependencies there within. And so within what we do in consulting, like in helping customers, like a lot of our customers are in the process right now of strangling the monolith, trying to do a cost-based or value-based assessment on like what does it make sense to start moving over into distinct services, being able to get the benefits of like the autonomy and more control over your services and more control over deployments, like providing that autonomy to your teams. So as and when those make sense, like great, let's do that for where the value is there, where the risk is low, the value is high, as well as obviously like net new ones. But it doesn't make sense obviously for every key part of your system. And so this is where like our value-based assessment comes into play, and how we look at it with customers. It's also really interesting to see how there's other ways of looking at it, like starting to take a more modularized approach to your monolith as well. Like it's breaking up into microservices doesn't make sense if you can just like keep it within the same monolith, but start modularizing more where it makes sense too.
Titus?
Yeah, I think that the important thing to keep in mind is microservices are good for limiting failure domains in case of there's a bug, there's a crash, there's a problem. Microservices are very good for if you have stateless components, subcomponents, services. The microservice model is going to be a whole lot better at how do you scale that up. The more subcomponents within your monolithic distributed system that are actually stateless, the better. You can spin up additional copies of all of those things with relatively little conceptual overhead. The question, as with everything, is how complicated is it to push quickly and reliably? How many humans are you going to have to coordinate with? How risky is a push? How is this going to scale? Like, it's the same as everything in software. The only really interesting questions there are, how does this work over time, and how does this work as you scale up in terms of more usage or more teams contributing? And I don't think that microservices is in any way really in conflict with a large code base sort of problem. Like, you can have multiple projects that are working in the same code base, and in fact you probably should, at least in my view, because then everyone is building on the same infrastructure, and you can have specialization and get all of the benefits of economies of scale, from that. I don't see the tension between those things.
Nice. We have a question from the audience, or more of a statement, that they are not using microservices. They're using their own code manager. How common is that? Do you guys hear that at all?
don't know what that means.
Okay. Anyone else? Nope. All right. That is very
That's
unique.
interesting.
It is very unique.
Yeah.
Interesting. Caller number 2, if you have more information on that, we'd like to address that. Otherwise, I think we can move on to, okay, we've understood sort of the concept of both of these living within the same world. But when we talk about specifically million lines of code, what are these special challenges when it comes to that? I'd like to sort of get back to the basics. What are these compared to smaller projects once you enter this domain? And Titus, since you were the last one, let's start with you. If you can talk a little bit about that.
I think once you start getting into the million plus lines domain, one of the things that's going to be really important is looking at how you're going to scale, right? There are a lot of build systems, CI systems, version control policies, version control systems that are going to start to have inherent, like, this is actually annoying just to operate on the code. Like, when I talk to companies that used to be small companies and now are, medium size, but they've been around for a little while, and they say, yeah, the first thing that you do day one is, before you sign the papers, turn on your machine and start pulling down a copy of the repo because it's going to take 12 hours. Like, there's a problem in there, right? And if you see that, you're going to get up to this million plus line world, then it becomes so critical to think about every component that goes into that, right? I think you really desperately need to invest in a real functional build system, by which I mean a build system with no side effects. The wonderful property that you get from a build system that is based on a functional programming language model instead of an imperative programming language model is you inherently have sandboxed every step of the build, and therefore it is free to cache it and distribute it, right? Your build can be fast and reliable and reproducible, and though you have to have that, right? And similarly, like, once you have that, you can build CI that you actually trust. You can get away from the world where people are like, hey, it worked on my machine. Like, this is silly. We're grown-ups. It needs to work in CI. That's the source of truth. And, but you have to start at these very low fundamental levels. And so many people have just cobbled together something that sort of worked. And they don't ever stop to, or they don't even necessarily realize that there's a better world out there that is within, a reasonable investment, and that the improvement in developer experience is going to be, it's magic. Like, I cannot express how frustrated I am thinking back on jobs before I was at Google and just thinking about all of the mysterious build problems and, like, how much of the time I had to make clean. Like, if you ever have to use make clean in your build system is bad. And, like, we're going to have to, as a industry, get to a better world. But it can be better.
Nice. Anyone else? Marc, do you comment on what are the special challenges around million lines of code over the 25 years, is it, that has been accumulating at MathWorks?
I mean, it's all the things that you just heard, and in your survey there, it's performance, it's partitioning, it's robustness, it strains the things that you sit on top of. Again, the underlying operating systems and all the tools tend to get strained as things get bigger. Right down to CPUs, the amount of RAM it takes to debug something. Just basically everything gets harder as things get bigger.
David, thoughts?
Definitely dependencies. I know it was on your list, but the issue with dependencies is always, well, there are two huge issues. One is when you end up with circular dependencies, if you ever get stuck into that nightmare, you will never be able to have a stable code base because someone changes something here and it breaks something there, and then they fix it there and it comes back and breaks the other thing. So acyclical graphs for sure. But even regularly, if your code is too dependent on other parts of your code, it becomes almost impossible for anyone to get any work done. you can't change anything in the shared modules without risking the entire platform, and you don't know which part you're risking. I'm not saying it's actually true. Of course you can. You can know that the class I'm dealing with only affects this. If you could do that, great. But how do you keep track of that for millions of lines of code? And the tools that you get from your compiler are helpful, but not so helpful. And also the other problem with dependencies is if you make a change and there are a lot of things dependent on, you have to build all of them in your validation build. I know Incredibuild can help, but at the end of the day, building 5 million lines of code in a single build is not going to get done in the time of a coffee break. It's going to take, more like a lunch or more, especially if you're running unit tests and integration tests and so on and so forth. So it becomes much more difficult for programmers to work after a certain point in time unless you manage to keep a clear dependency graph and try to keep things a little bit more independent. That's, I think, one of the reasons why microservices became such a popular buzzword, because the idea was my team works only on this little piece of code, and it has 100,000 lines of code. No big deal. Compiles in 3 minutes. And if that works, it's great. But when you start breaking out and things start becoming dependent on other things, it becomes much more difficult. How do you keep the independence between the parts, and how do you manage those dependencies between different parts, I think is really one of the biggest challenges.
So I know Zoom has the hand gestures that you can click on, but I saw a real hand gesture from Titus that kind of went like, So I want you to explain that, Titus, please.
That sounds like designing your system with fear. And that, no, if you have sufficient unit tests, literally everything in our code base, in C++ and other languages, because of JNI and Swig and all of those things, depends on the packages that my team maintains. We make changes on a hourly basis. It doesn't matter because we can run all of the unit tests for everyone. And yeah, some of those are flaky, but we know how to read those and interpret those. You have to have signals to predict whether or not something is safe, and then you just move on. I do think that you're right in don't let your dependencies run wild. There needs to be a layering, there needs to be a cyclicness. You need to be pretty clear on what is, here is a dependency that we intend everyone to use versus accidental coupling. Right? But in the end, the idea of this is only going to build, over lunch or whatever, again, if you have the right sort of large infrastructure, distributed compilation, parallelization, caching, all of these things, this is all very, very doable. We just have to get out of the mindset that you're going to build it on your desktop. Over time, developers produce a lot of code, and single machines are not going to do it. There's a scaling mismatch between those things.
I mean, I definitely agree with you. The only thing I'd say is once your dependencies become too complex, then you can't parallel build anymore.
That's
if it's complex enough. In other words, if things are, let me say it differently. You can't parallel build things that are dependent on the thing that you're parallel compiling with.
Sure.
So if you have enough of those dependencies, it becomes much harder to manage your dependency graph and distribute out your compilation across multiple machines. I'm not saying you can't manage dependencies. I'm saying that's a challenge when you get to a large code base, that you have to manage where those boundaries are. You definitely can manage it. I'm not saying you should break all dependencies and everything becomes its own little, standalone. That's also sounds enticing until you realize you're still dependent across contracts and functionality. But there's a fine line between, everything is dependent on everything else, and then you're in compilation nightmares, or nothing's dependent on anything else apparently by compilation, but they all really are dependent on each other in terms of functionality, in which case you have distributed monolith, and you have to find the right balance between the two.
I mentioned that is, you just mentioned testing, which is of course very important, but it does not always solve all the large-scale problems. So you mentioned all boundaries and the difficulty in finding these boundaries or defining the boundaries, which makes it difficult to move to the proper modules or microservices. So for example, if we think of avionic system and we need to do some change in a certain module, making sure that this change didn't affect anything else in another module or in another place. Testing is one thing, and then integration testing and system testing, and the whole thing, while being larger, is of course much more complex.
Yeah, I would agree with that, but I think that the model that we need to get to is not one of we run all of the affected tests for everything all the time, but one of the ideas that I've really liked for a while is your CI system is doing exactly the same work that your production monitoring system is doing, right? Everything that you could assert as an invariant in your CI world, in your unit tests and your integration tests, is exactly parallel to the invariants that you are monitoring in production, right? You're going to fire off an alert when something goes out of threshold. You're firing off an alert when the invariant doesn't hold, right? It is purely a shift left view of the same fundamental idea, right? And much like in monitoring, we know that there are things that you're going to miss, right? Tests are not a proof that things are correct, right? But at the same time, you're not going to try to run anything without monitoring and think that it's going to stay up, right? Everything that we're doing in the entire developer workflow, from unit testing, integration testing, like code review, pre-submit, canary, integration tests, all of these things, right? It's part of a continuous spectrum where the earlier that you can detect the problem, it is much cheaper, right? But you don't have proof that that is efficient detection until you get all the way up to canary and deploying to production, right? And so a lot of these arguments are like, oh, tests sometimes miss something. Like, yeah, of course tests sometimes miss something. Sometimes your system goes down because your monitoring wasn't sufficient either. Like, stuff happens. It's not proof. But what we have to do is focus on what detection of a defect can we do at this phase for a reasonable cost in time and compute resources before moving on to a later phase in the deployment and the developer workflow.
No one, I think no one mentioned keeping conceptual integrity, maintaining documents. These are pretty difficult.
I was also going to jump in, like David touched on another area that we haven't really talked about, which is the developer experience. So if you're joining as a new developer on a team, the ramp ups are obviously a lot longer. And if you look at the alternative approach, you're taking a microservices-based approach, right? Like once you start getting into domain-driven design, like people feel like they're closer to the business value, so they really like then have a sense of ownership. Where with that sense of ownership, like they start to see like the impact that they can have on the business. So they're ramping up quickly. There's less churn as well. Whereas like in the million line of code, like with that long ramp up time, trying to find whoever has the answers, whoever built this old thing that's been around for a long time, like you feel pretty crappy and like you're wasting a lot of time and inefficient. And really, like people don't want to feel inefficient. They want to feel a little bit. They want to feel productive. And I think this is another thing that like domain-driven design gives to people is like feeling productive. Much like when you move a card over on an Agile board, there's a reason why a lot of times like we're still using a physical board because like it feels really good to move it over. Same again with like being productive and having that sense of ownership of what you're producing. So developer experience being a pretty key one here too.
Excellent. Anyone else have what to say on the topic? If not, we can. Yeah, go ahead, Marc.
I'm just going to throw out, I mean, certainly all the things that you're hearing are good, and the notion that dependencies, certainly we don't allow circular dependencies at build time, but the reality is that systems are coupled, and as much as we love modularity, systems are becoming that much more coupled in reality. So one of the things that microservices gives you is the ability to have that decoupling at build time with that coupling at runtime. And so you actually have to be able to handle both of those situations. And as much as we love unit tests and all the shift left stuff, and we're certainly trying to do all the things that Titus just mentioned, particularly when you're building systems that go into mission critical applications, real-time systems, spacecraft, aircraft, et cetera, often things that you don't have a chance to turn around and fix it on the fly, especially if it's millions of miles away. You really do have to test very extensively to make sure that you're not missing any of those edge cases and special cases. And so all of the things that you've heard today come together. They're all needed, I guess would be my message. It's a union of all of the above.
Yep, and I think Amir mentioned, but I just wanted to touch on some of the practicalities of managing and keeping up with design documents, internal changes in the code base. David, you mentioned when we were talking previously, you mentioned something about docs within the code. Can you elaborate on what you think about that?
It was just an idea that got floated recently. I've actually seen some teams use it successfully, where they create a directory within their Git repository called docs, and they create markdown files inside for whatever the high-level design is going to be. We don't get down to the teeny level where it's going to fall out of being correct very quickly. But what's nice about it is that you then commit that document into a branch, and you do a pull request, and then you get the full pull request experience around your design. So instead of people sitting around in real time talking about it, which also happens, I mean, obviously they don't do it all online, but people can put comments into your document with what they think is a flaw in your design, and then you can comment back and you can resolve those comments, and in that way the process gets kept inside that pull request permanently, which gives you not just the final document that you created, but it actually also gives you like a nice history of what happened and why it happened and what the considerations were, what the discussions were, what the different versions were along the way until you get to the final thing. It doesn't give you a nice wiki, which is what most people want when they talk about documentation, but it is a nice process for designing documentation. And it stays close to the code, so that theoretically, if you change this to the design, either right before or right after another pull request that's going to actually do the code change, you can kind of tie the two together if you want to. I thought it was cool. Can't say I've done it personally, but I'm a little bit, but not so much. But it definitely works for the teams that tried it.
All right, any comments from the panel on the concept of docs with code or anything else that you guys do in order to get a hold of design documents and internal changes in these large code bases?
I think that was the biggest improvement in documentation health at Google in the last 10 years, was moving docs to code.
Oh.
Exactly the way that was just described.
Nice. I mean,
nice to hear. Fabulous. Any other tips, points of view when it comes into design documents, internal changes that are, I guess, not docs in code? Any other practices out there?
I mean, there's always the standard problem that your documentation is never up to date. Or not never, that's not fair. It's very difficult to keep your documentation aligned with what's actually going on in your live code base, because people make changes to code and they don't necessarily remember to go and make the changes to the documentation as well. So unless you do something like, if you have a pull request that has to contain a change in docs also, even then it's, if people just change something small, it's very difficult to enforce the accuracy of the documentation that you do, so it often falls behind. A lot of people prefer the code to document itself. So it's definitely, you have to find that balance, because sometimes high-level architecture is not really expressible in code as well. A little bit you can do it, but on the other hand, these things fall out of sync with your code base pretty quickly.
In some cases, not necessarily the design documents, but some of the documents are maintained in a wiki environment where anybody in the organization can maintain the document, and then if there is something which is not up to date, anybody can, we find it, can come in and make the change.
If they do it. The trick is not can you. Wikis are great if someone does it. Like Wikipedia, people spend time doing, so it stays up to date. I don't know. Every news item within 5 minutes ends up on Wikipedia, which is amazing. But on the other hand, with code, people don't like to write documentation, so it tends to get somewhat ignored.
It depends. It depends, I think, on the component. So suppose you have an infrastructure, internal infrastructure, and you want people in the organization to use it correctly. So you may have the documentation of the infrastructure on the wiki, and then if there are changes, the infrastructure team can maintain the wiki. Or the users, if they have a good example of using something.
Yeah, it's definitely going to happen. I'm going to poll the panelists for a minute. When you go to touch a new part of the code that you haven't touched, is the first thing you do to look at the wiki, or do you find someone on that team and send them, an email, chat, something saying, "Hey, what's going on here?" I can tell you, I find a person.
I have not had a whole lot of good luck with Wiki. It is a great sales pitch of anyone can change it, but in practice, if everyone owns it, no one owns it, and it falls out of date real easy. Partly because it takes a certain level of security and certainty to be willing to say that this is the answer when you don't know for sure. And so tiny simple things might get updated, and anything that's more substantive, the experts haven't paid attention to the docs in a while, and the novices don't have enough certainty to make the change. And I think having clear ownership is healthy.
I saw it working quite well for how-tos, how to do things like manuals for using internal products. And then if things change, people do amend the wiki because they want it for themselves. Instead of maintaining a document on their own desktop, they just go in and amend the document for themselves, which also would, of course, be used by others.
Yeah, I think it depends on the type of document. Something that is a straightforward step-by-step, this is do this, onboarding things, how-tos on a basic tool, bigger conceptual documentation, or this is the state of the world, those things don't so much work.
Right. I mean, the other thing you have to realize is people don't generally work on things that don't get them back value. And documentation on your design, if you spend time thinking about it, gets you back value because theoretically if someone reads it, it'll save them time understanding what to do. But there's no customer value for spending 3 days writing up a document on what you just coded. So it becomes more difficult to sell people on the idea that they want to do that. Not saying that it doesn't happen. It's just less likely.
You can gamify it. That's right. You can gamify anything these days.
You can gamify anything, but yeah.
I see a comment on the chat regarding REST APIs. So for APIs in general, or specifically for REST APIs, you in many cases have the documentation being created from the code. So for example, you ran Swagger or any other tool, and you have the proper annotations or things inside the code which can create the proper documentation to be used by your internal customers or external customers.
Yeah.
Right. So I wanted to ask you guys, since our topic is million lines of codes, and each of you, of course, coming from different perspectives within the organizations. Let's talk a little bit about the stakeholders. Amir, I know that in your previous role, you were a chief programming officer at Converse. Titus, you have a pretty central role as well. Is there a centricity to this as a stakeholder? Does one need to be this central role? What other stakeholders involved when we're talking about million lines of code projects?
So I can tell a bit about the role as chief programmer. It's twofold. It's enforcement and advisory. So for the enforcement part, you want people to use the same infrastructure, a narrow list of programming languages. You do not want the product to have a new programming language because some programmer decided to write this module with another new thing that he just found. Even if it is a great programming language, it should be maintained later on by the teams. You want to have a very clear baseline for what are the operating systems and versions to be used. So this part would be enforced. On the other end, there are things that you want to advise because you cannot, in a way, dictate for the teams how to do many things. But if you come up with advice and in some cases boost, you say, okay, I advise you to do that, and we have some infrastructure to help you do it. So you can influence the way things are being done, and at the end, you want to preserve conceptual integrity. You want people to be able to, come from this part of the product to another part or to another product, company, and see things work in a way similarly. So this is how I see it.
Yes. So anyone else want to comment on that? Because we have, otherwise we have a question that it kind of struck my interest talking about Agile and not to...
I think Titus was about to add something. I at least want to hear because Google for I'm sure Titus has what to say about how it is being done in Google.
Right. No, I completely agree with what you said. I think it's really important to counterintuitively, the larger your company gets, the more you need to not give developers options. Like use a narrow set of languages that you have good infrastructure for, that is well supported, that you can centrally upgrade the compiler instead of, hundreds of teams having to do that once every 5 years. Like you're going to get better consistency, fewer bugs, more performance, all those things. The more that you can centralize in a lot of cases, the better, so that people can spend the time, like the choices and creative time focusing on product decisions instead of infrastructure ones, right? The more that you can narrow laser focus the infrastructure choices, the better. That's it. But otherwise, I completely agree with what you said. Yeah.
And I just have to mention, I did get a nice shout out in our Q&A that said they will invest in my startup for gamification of documentation if I was to do that. So I'm glad I got that in. And let's talk afterwards. So we'll think about our business plan. But question about Agile. So not to quote any 90s pop songs of chasing waterfalls, but are the waterfalls still in the topic of million lines of code projects, or are we doing Agile? What do you guys think about that? Is waterfall dead? Is it necessary? Is it a must for major lines of million lines of code projects? Marc, why don't you take us with that one?
Sure. So MathWorks was founded as a company that targeted the control system market, and the common approach in controls is what we call successive loop closure. So you have outer loops that are doing things like navigation, and you have inner loops that are doing things like keeping the wings level on an aircraft. And so you actually need both systems. You need some form of global navigation that's giving you your trending and pointing you where you're going. And then Agile is great for those tight inner loops where teams are working on a high frequency loop of doing the actual work and responding to things as they come up.
Nice. Titus, you gave a thumbs up. That's excellent. Anyone else have comments on the waterfall versus Agile, inner loop, outer loops? Reminds me of the Beltway in Maryland.
I mean, we still see like a knowledge gap out there. I was talking to a team a couple of weeks ago who were like, oh yeah, we're now getting mandated to move to this new Agile thing. I was like, wait, you're only now and you're referring to it as new? So it's pretty stunning what you'll still see out there, and the knowledge gap as to what Agile means and different ways of doing it and how to be successful with it. So it's not all unicorns and rainbows.
And it's how fast do you need to be in order to really be agile? Is that another thing you've been hearing? I mean, you can say you're agile, but actually the speed element is part of it, as we hear that from our customers in the world of acceleration. Are there any thoughts about it? Is there sort of a golden time frame that would be agile or not? Or would the real agile players please stand up? No, there's nothing here. No. I try to put some context around it. All right.
I'll throw you a quick answer to that. And same thing, people ask, what does it mean to be real time? And that depends. If you're controlling a laser beam, real time may be in picoseconds. If you're controlling a telescope, it may be in seconds, at least if you're trying to point it at a particular star. So all of these things are context dependent.
Yeah, and that's when we invented something called near real time, and then everyone was happy.
That's one way to finesse the problem.
Exactly. Another question we have coming in is around tips for dealing with chasing the master or main branch in large-scale projects. David, I saw a little smirk with you. Do you want to take us with that?
I mean, it's a matter of taste. I personally don't like branches that live more than a couple days. Chasing the master happens because you don't commit your code. You're aiming too big, and it's a fallacy that programmers have that they think that they can do a whole bunch of things all at once. Just do one small thing and get it in. And people say, but what if I have to change the infrastructure? You know what? You do have to change the infrastructure. So check in a duplicate copy of the infrastructure, then go fix all the other parts, and then remove the old one. But don't try to do it all in one big check-in that has 15,000 files in it. You're not going to do it well, and you're going to end up colliding on merges, and then you're going to make a mistake. It's much easier to work in small things. I try to push all the developers I work with, check in within 24 hours. They look at me, 24 hours, what can I do in 24 hours? You can write 3 lines of code, check it in. What is going to hurt you? Okay, you want to do 100 lines of code? Fine, take 2 days. But when you start having code changes that you're keeping alive for weeks, not in a 1 million+ line code base, because there are going to be 20 other developers touching that same code or something else dependent on it or something else, and you're never going to be able to pull yourself out of that mud. So short, get it in, and just don't break anything. In other words, it doesn't have to be finished. It just has to be something that didn't break anything else, and I can get in and then build on what you've already done. I think that makes it much easier than trying to, I don't know, catch up always.
And the keyword here would be refactoring. Do the proper refactoring in order to bring the big thing easily, rather than doing the refactoring with the new feature together, which would become chasing the main branch. So adding a proper abstraction in order to be able to bring the new feature. The abstraction by itself might be just a refactoring that keeps the same exact behavior, and then you can bring the new feature, and the changes are much smaller. This is just, following David, what you raised, I would say.
Yeah, so meanwhile, we were running a couple of polls in the background to keep you guys, those who like to multitask, busy. And one that came out, which is what is your biggest challenge when orchestrating million lines of code? And I just wanted to kind of echo this to see whether what we were talking about is resonating with the audience. And the number one at 56% said dependencies. I don't remember which panelist mentioned dependencies, but you win 1 million lines of code. I'm just kidding. But that is definitely something that we discussed. So it's interesting to get the audience's impressions around that. I think the runner-up was building and deploying in new release at 24% of the audience, bug detection 20%, and the last but small 5% said mitigate security issues. So it's interesting to see how that came about as we were talking and discussing that. Any reflection points on that? Are we all sort of in agreement? Did it shock you to see who's, the I guess the big shift towards dependencies versus other things?
I think dependency management is the hard problem for software, just in general.
In general, right? Not just metal lines of code. It's just in general.
Well,
I mean, especially if you're talking about pulling in dependencies that are possibly outside of your team or your organization, like those are going to have different priorities, different stability models. We don't talk about how stable an API is. We just, hey, this JSON library solves my problem. Like, I'll just download that and then pretend that it's stable for 10 years. Like, you get diamond dependency problems, incompatibility, bugs. Like, we don't, as an industry, have a actually good or philosophically sound answer for how do we manage networks of dependencies and software that we don't control, especially. I would be disappointed if people didn't say dependencies was the hardest problem.
And tying that into security, you certainly can't wait 10 years to update anything. It's more like 10 days.
Yeah, definitely. Yeah, so we're getting close to the top of the hour. I'm sure we can keep going, but I wanted to throw out an interesting question for, really the next generation. I saw that Titus, you had mentioned that you joined the ACM, IEEE, and AAAI Curriculum Standards Committee. And I know that David Schwartz has an MA in education, and I'm sure others, on the panel can weigh in as well. But are we preparing the next generation of our college grads to be able to come out and, face the reality of major, million lines of code projects? And I'll let Titus start with that.
We don't teach people how to read code. We don't teach people how to be on a team. We don't teach people that the job that they're going to have in industry is probably not one of sit down and write a ton of code. It's going to be sit down and understand a ton of code and talk to 5 people and figure out like where to make a small change, right? Like what we prepare grads for is programming, which is not software engineering. I don't know that we can do a lot better. It's very hard to get those practical and collaborative skills in the relatively sterile environment that is a university program. I think the tension there is going to be very difficult, but in practice, I think it's always going to be some challenging ramp up, especially for new grads entering a professional environment.
Hey, Titus, I haven't done one, but I've had some friends' kids do these coding boot camps, right? The immersion programs for 3-6 months, and a lot of in what they tell me, they learn a lot of the agile practices. They learn a lot of working as a team, things to make it a lot more of a real world experience. And certainly I had 20 years ago when I went to college, and I was like, great, I left all of that behind, and absolutely nothing that I learned I applied to my first day at work. And so if the colleges are still in somewhat the same position that they were 20 years ago, where it's a lot more theoretical based rather than practical based, is there stuff that they could be learning from these boot camps, which seem to be doing a pretty solid job, at least from what I can tell on the outside, with making it a practical experience?
I think some, but I'm still a little worried, even in a coding boot camp environment, you're going to be working on a team that is not how any other team is ever going to work, right? How rare is it to have a team that is formed with no prior basis and everyone on the team is new? That's not how things work. You're going to have a mix of seniority. You're going to have, iteration. Oh yeah, we all worked on the previous project and now we're starting up, V2. So I think there's a lot to be said for the coding bootcamp thing in terms of it is a little less focused on assessment and a little less focused on theory, a little bit more focused on teamwork and practice. There's a lot to be said for that. I think we need both, but even then, there's still going to be a meaningful gap between that and what you actually need day one, at least in a lot of places.
What we find is very helpful is internships where students can come in. You have one at Google as well. Students can come in and get experience working with a large code base, seeing what the practices are, how things are done. And unless you're in a graduate program where you're working on a project that, as you say, has history, you're just not going to get that in a university environment. And so there's no substitute for doing.
what comes before a large code base, I would say, is reading code. Titus just mentioned that. And I must say that today I'm giving my students read much more code that I was used before. Reading code is very important. Not only writing new things, but amending code, adding things to, I'm giving them predefined or something, a project that, okay, you have this and you have to use it, and now you have to add something. So this is something that can be done. Preparing them for a million lines of code, this is much more difficult to do in college environment. That also goes back to the documentation topic, and someone mentioned the term about self-documenting code, which is my favorite buzzword, that, you know, well-structured code really should be readable and should be understandable. And ideally, I mean, yes, the high-level documentation is really good for the architectural principles, but a well-written piece of code, you should be able to pick up and understand what it's trying to do. And unfortunately, that's not the case as often as it should be. Which again, requires the proper attention from the teachers to bring enough time into the course, into grading. Yeah.
Excellent.
It's an example where less is more often.
Yeah. So with the 2 minutes left that we have, I'd like to, first of all, I'm glad we ended on a note for the future, helping the future generation and our input on what we can help the next generation.
It is interesting to say, I would just add that, you know, we always promise the future, the next generation, that things would be easier for them. And I'm not sure this is the case. Things would be probably more complex.
Yeah, so if this webinar is called MLOC, Million Lines of Code, I think even just next month it'll be GLOC already, maybe a billion lines of code. But yeah, it definitely, the code inflation and of that sort is definitely, they're depending on, standing on our shoulders in order to overcome some of these challenges. But on that note, I just wanted to say, first of all, thank you so much to all our panelists. We've had so much love given to us just for bringing this topic to a conversation and having all of you to the point where we've started to establish a community around a million line of code projects. So watch this space for that, be able to take sort of the conversation that we started here and to continue off into community concepts that I think it will be fun to continue. So again, thank you so much for all the questions that we got, and we have a lot more that unfortunately we didn't get to. We will follow up via email specifically, and if any other questions as they come in, please feel free to send them to us. And again, I wanted to thank you all again for spending time with us. If you feel like this could help benefit others that friends or colleagues, then you will get a on-demand recording of this webinar that you can share with them. And it'd be great to also hear from you if you have any other topics around that. And the way we know whether this was good for you is with a survey. So we have a survey at the end. Please let us know how we did, but more importantly, topics for the future, along, of course, the lines of million lines of code. No pun intended. And again, thank you so much for your time, and have a wonderful rest of your day.